All right. Welcome back, everyone, for another deep dive. Today, we're going to be diving into the world of antimatter.
Ooh.
So, this is a topic that I've always been really fascinated by. And I know that a lot of our listeners out there are sci-fi fans. So we're going to be taking a deep dive into an excerpt titled Theory on the Use of Antimatter as Fuel.
Okay.
Really trying to get into, separate the science fact from the science fiction and see, is this something that could really power us to the stars?
Yeah, it's certainly a tantalizing idea. I mean, the source lays out a pretty compelling case.
Okay.
And it all starts with just the sheer energy potential of antimatter. It all kind of boils down to this concept of annihilation.
Okay, annihilation. That sounds kind of intense.
Yeah.
So what exactly are we talking about here? What happens when matter meets antimatter?
So imagine if you can matter and its antimatter counterpart, they collide. But instead of an explosion like we typically think of, their entire mass converts directly into energy. Pure energy.
Okay.
And this is really, Einstein's famous E=mc² equation.
Right.
But in its most dramatic form.
So we're not just talking about a powerful explosion. We're talking about total mass to energy conversion.
Exactly.
That's got to be way more efficient than anything we use now, right? Like orders of magnitude.
Oh, absolutely. Orders of magnitude more efficient than anything that we can even imagine with our current technology.
Wow.
And to kind of grasp the scale of this,
Okay.
the source gives a really interesting example.
Okay.
They say that a single gram of antimatter annihilating with a gram of matter would release energy equivalent to the atomic bomb dropped on Hiroshima.
Wow. Okay, now that's a pretty sobering comparison.
Yeah.
I'm starting to see why everyone gets so excited about the potential here, but I'm guessing there are some pretty significant buts.
Oh, absolutely. Yeah, there are some major caveats here.
Yeah.
It's almost like a cosmic joke, right?
Yeah.
We've figured out how to make antimatter, in places like the Large Hadron Collider. But we can only make minuscule amounts. I'm talking like a handful of atoms at a time.
So it's like we have the key to the treasure chest, but it's locked inside another even harder to open chest.
It's a very apt analogy.
Right.
Yeah, the source really outlines a couple major roadblocks.
Yeah.
And the first one is cost.
Okay.
Production costs are astronomical. We're talking trillions of dollars per gram. Trillions, yeah.
Wow. Okay.
And then on top of that, there's the storage dilemma.
Right, because you can't just put it in a regular container, right?
Absolutely not. It would annihilate with the walls of the container.
Right, so we need some really outside-the-box thinking here when it comes to storage.
Yeah, and this is where things get really ingenious.
Okay.
So scientists have developed something called a penning trap.
Okay.
And it's essentially a device that suspends antimatter in a perfect vacuum using magnetic fields. So you can almost imagine like a tiny invisible bottle made of pure magnetic force that's holding these incredibly volatile particles perfectly suspended.
So it's like this high-stakes levitation act, but at an atomic level.
Yes. Exactly.
That's incredible.
Right.
But how do they even get the antimatter into the trap in the first place?
It's an incredibly delicate and complex process.
Okay.
It involves slowing down the antimatter particles and carefully guiding them with electric and magnetic fields. But, the amount that we can actually store at any given time is still incredibly small.
So that really brings us back to those hurdles you mentioned. It sounds like we need a triple breakthrough here.
Yeah.
We need to figure out production, we need to figure out storage, and then I'm guessing actually using the stuff for something practical, like propulsion.
Yes, you're exactly right.
Okay.
Each of those is a monumental challenge in and of itself.
Right.
But let's just assume for a moment that we do overcome those hurdles. How could we actually harness the power of antimatter to propel a spacecraft?
Right, because it's not like we're going to be pouring antimatter into a gas tank and hitting the interstellar highway anytime soon.
No, definitely not.
What does the source say about how antimatter propulsion could actually work?
Well, it outlines two main concepts.
All right.
Each with its own set of complexities.
All right.
The first is what they call direct annihilation propulsion.
Okay.
And it's essentially you're carefully controlling the reaction between matter and antimatter. And the resulting release of high-energy particles like gamma rays to generate thrust.
Gamma rays, those are the ones that can, pass through pretty much anything, right?
Right.
So I imagine that makes controlling them for propulsion a little bit tricky. to say the least.
You've hit upon a major challenge with this approach.
Okay.
It's kind of like, imagine trying to harness the energy of a nuclear explosion to push a shopping cart.
Yeah, imagine you need a pretty strong shopping cart.
You would need incredibly robust and sophisticated systems to channel and direct that power, not to mention the shielding to protect the spacecraft and crew from radiation.
Yeah, that's a good point.
Yeah.
Okay, so direct annihilation sounds a bit like trying to, wrangle a wild beast.
Yeah.
What about the other concept, the one that the source calls hybrid fusion antimatter propulsion?
Right.
That sounds a little less, explosive.
That's a good observation.
Okay.
Yeah. This concept is more about using antimatter as a spark plug.
Okay.
So it relies on nuclear fusion, the same process that powers the stars.
Right.
The idea is to use a tiny amount of antimatter to trigger and sustain a fusion reaction.
Okay.
And then that becomes your primary source of propulsion.
So instead of wrestling with gamma rays, we're trying to, ignite a tiny star to push our spaceship.
In essence, yes.
Yeah.
It's a fascinating concept, especially because it kind of leverages ongoing research into fusion power here on Earth. And plus, it potentially uses much less antimatter.
Okay.
Which would be a massive advantage, considering those production and storage bottlenecks we talked about.
Absolutely. So we've got these two potential paths to antimatter propulsion, one that's brute force, the other a little more finesse. Both sound insanely complex, and I'm guessing neither is exactly ready for a test flight.
Yeah.
Where does the source say things stand, realistically, with all this?
Well, the source is very clear. Both of these concepts are firmly in the realm of theoretical possibility.
Okay.
We're talking about a convergence of multiple still developing technologies, even with breakthroughs in production and storage. Harnessing that energy for controlled propulsion is a monumental engineering challenge.
So to put it bluntly, it sounds like we're still quite a ways off from, ordering antimatter fuel online and booking a trip to Alpha Centauri.
You could say that,
okay,
but the research itself is fascinating, and it has implications beyond just rocket fuel. Yeah, the source touches on some other potential applications of antimatter, ranging from the practical to the slightly unsettling.
Well, this is where it gets really interesting. Let's dive into those after a quick break. Stay with us.
Yeah. So, before the break, we were talking about all the challenges with antimatter for propulsion.
Right, but even if, interstellar travel is still a long way off. I mean, this stuff has to have other uses, right?
Yeah.
The energy density alone is just mind-blowing.
Oh, absolutely. The source actually dives into some of the potential applications.
Okay, what do they highlight?
Well, one area is emergency power sources.
Okay.
Imagine like a device that could fit in your hand, but could generate enough energy to power a small city.
Whoa.
For a limited time, of course.
Of course. But still.
I mean, that would be, invaluable for disaster relief, remote locations.
Right, exactly.
Even, powering future spacecraft systems. But right here in our solar system.
Precisely.
The source even touches on using antimatter for things like medical imaging and cancer treatment.
Really?
Yeah. But, those are even further down the line in terms of development.
Okay. Yeah, makes sense.
But there's another side to this, though.
Okay.
One that's a bit more concerning.
Yeah, I think you alluded to this before the break.
I did, yeah.
I have a feeling this is where the conversation gets a little heavy.
It does.
Okay.
Because whenever you have a potential energy source this potent,
right,
the question of weaponization inevitably comes up.
Right. Of course, yeah.
And the source does acknowledge the possibility of antimatter weapons, but it stresses how far-fetched that is, given all the current technological hurdles we've been talking about.
Right. I mean, it's kind of a relief that creating even, tiny amounts of this stuff is so difficult and so expensive. It's almost like a built-in safety mechanism for now.
It is, in a way.
Yeah.
But it also kind of underscores the need for, really careful consideration and international cooperation as this technology advances.
Yeah, absolutely.
We need to be having these conversations now, even if practical applications are, decades away.
Right. Okay, so let's shift gears a bit here.
Okay.
And look ahead a little bit.
Okay.
Even with all these challenges, research into antimatter continues. What's driving that, aside from, those sci-fi dreams of spaceships?
Well, as the source points out, antimatter isn't just about practical applications.
Oh, yeah.
It's also it's a window into some of the deepest mysteries of the universe. Right now, a lot of the research is focused on fundamental physics.
Okay.
Really trying to understand, like, antimatter's properties, how it behaves at a fundamental level.
So it's less about, building warp drives and more about probing the very fabric of reality.
Exactly.
Okay.
Yeah. So, for example, there are experiments going on right now
Okay.
to determine if antimatter responds to gravity in the same way as regular matter does. Which, it seems like a pretty basic question.
Right.
But the answer could have really profound implications for our understanding of the universe.
Wow. It's amazing to think that, like, the very existence of antimatter challenges some of our most basic assumptions about, how the universe works.
It really does.
It makes you realize how much we still don't know.
Absolutely. And that's what makes this research so captivating, right?
Yeah.
It's not just about the destination. It's about the journey of discovery.
Right.
And pushing the boundaries of human knowledge.
That's a good way to put it.
Yeah.
So, speaking of that journey, what are some of the key areas that researchers are focusing on right now? What are, like, the big questions they're trying to answer?
Well, we touched on the production challenge.
Right.
Finding more efficient and cost-effective ways to create antimatter. That's huge.
Okay.
And then there's the storage issue, right?
Right.
I mean, these penning traps are incredible, very sophisticated pieces of technology, but still very limited in terms of, how much antimatter they can hold and for how long.
Right. And then there's the whole issue of how to actually use it, right?
Exactly.
Whether it's for, propulsion or some of these other applications.
Right.
Controlling that energy release it's still a huge hurdle.
It is. We're talking about harnessing forces that are orders of magnitude
Right.
more powerful than anything we currently work with. So it really demands advancements in materials, science, engineering, our understanding of high energy physics.
So it's not just one field. It's like collaboration across multiple disciplines.
Exactly.
You got physicists, engineers, material scientists, all working together to try to unlock the secrets of antimatter.
Yeah, and that's what's so exciting about this field, way. It's really a testament to human ingenuity and our drive to explore the unknown.
Yeah.
Even if we don't see practical antimatter applications in our lifetime, just the pursuit of this knowledge is pushing us to think bigger, bolder,
Right.
and to really challenge the limits of what's possible.
Well said. Yeah.
Yeah.
So even if we're not booking our antimatter-powered cruises to, the Andromeda Galaxy anytime soon.
Right.
The research itself is incredibly valuable, right?
It is.
It's pushing the boundaries of what we know, maybe even what we think we know.
Yeah, and sometimes the questions raised are just as important, if not more so, than the answers we find.
Ooh, I like that.
Yeah.
So before we wrap up this deep dive, is there anything else from the source that stood out to you? Anything our listeners should ponder as they go about their day?
There is one thing, and it kind of ties into what you just said about, the questions being as important as the answers.
Okay.
So the source briefly mentions something that I find really fascinating.
Okay.
Which is that the very existence of antimatter is one of the biggest unsolved mysteries in physics.
Oh, wait, really? I thought we kind of had that figured out.
Well,
Matter and antimatter created in equal amounts during the Big Bang, and yeah.
That's the standard model. Yeah.
Okay.
But here's the catch.
Okay.
If that were entirely true, then the universe should have ended up as pure energy.
Oh.
Matter and antimatter would have just annihilated each other completely, leaving nothing behind to form, stars, planets, us.
Yeah. Okay, that's a bit of a problem.
It's a slight problem.
I'm guessing there's more to the story.
There has to be.
Yeah,
I mean, the fact that we exist, the fact that the universe is full of matter,
right,
means something must have tipped the scales, right? There must be some asymmetry, some subtle difference between matter and antimatter that we haven't yet discovered.
So the very substance that we're trying to figure out how to use for interstellar travel might also hold the key to understanding why the universe exists as we know it.
It's a mind-boggling thought, isn't it?
It is, yeah.
The very existence of antimatter points to a fundamental gap in our understanding of the universe's origins and evolution.
This has been an incredible journey.
It has.
From the potential of antimatter to power starships to the profound questions it raises about, the universe itself.
Right.
I mean, it's clear that this substance is anything but simple.
It really is a microcosm of the scientific endeavor, right? A journey of discovery, innovation, and the constant pursuit of knowledge.
Well said. So to our listeners, as you go about your day, let this be a reminder to Stay curious, keep asking questions, and never lose sight of the wonder and mystery that surrounds us.
Absolutely.
Who knows what incredible discoveries await us, just beyond the horizon of our current understanding.
Until next time, keep exploring.
Yeah, it's kind of crazy to think that something like so small,
Yeah.
like something so fundamental to the universe existing at all is something we're trying to figure out
Yeah.
how to use to, power spaceships and stuff.
It really speaks to the interconnectedness of everything, doesn't it?
It does, yeah.
From, the tiniest subatomic particles to the vastness of the cosmos. It's all part of the same intricate tapestry.
And that brings us back to, the excerpt we've been exploring, theory on the use of antimatter as fuel.
Right.
It's given us a lot to think about.
It has, yeah. It really kind of, brings up the fact that even when we're talking about something as seemingly futuristic as antimatter propulsion,
right,
we're inevitably touching on some very fundamental questions about the nature of the universe.
Right, like that whole matter-antimatter asymmetry.
Exactly.
It's humbling to think that we're really just scratching the surface of what we know.
Absolutely. And that's what makes the journey of scientific exploration so exhilarating.
Yeah.
Each new discovery, each question that we answer just opens up a vista of new questions and new possibilities.
So as we wrap up this deep dive into the world of antimatter, what's the key takeaway you'd want our listeners to ponder, going forward?
I think the key takeaway is this. Antimatter is much more than just a potential fuel source,
Okay.
It's really a key to unlocking some of the deepest mysteries of the universe.
Right.
It's a reminder that our understanding of the cosmos is constantly evolving.
Yeah.
And that there's always more to learn.
Absolutely.
Always more to discover.
Well said. So, to our listeners, as you go about your day, let this be a reminder to stay curious, keep asking questions.
Yes.
And never lose sight of the wonder and mystery that surrounds us all.
Yeah.
Who knows what incredible discoveries await us just beyond the horizon of our current understanding.
Until next time, keep exploring.
And we'll see you next time for another deep dive.